Hi, this is Chase Yarbrough, and I'm going to be presenting my group's project on return on financial investment in American public school systems. This is our final project for CX4240 at Georgia Tech. So first we want to go into the motivation of the project that is. Uh, and that is that given a limited amount of funding each year, state and federal administrations are tasked with investing in various aspects of public education in order to improve the overall quality of learning. And our goal was to create a tool that demonstrates which areas they should be spending and how they should invest their money in order to receive the highest return and the highest quality education. This just makes sense. We want people to, be educated in how they're making these important financial decisions. And so from there, we built our problem statement. And the problem statement is we want to find with X dollars invested in Y area, what is going to be the result of an average increase in educational performance, and we'll call that Z. Now, from there, we have to have a way to track this educational performance, right? And so to do that, we utilize the standard testing data from NAEP, that's the National Assessment of Education and Progress, as a metric to gauge the change in education quality. And so the way that they're measuring this is they're administering a standardized test in every state every 2 years to fourth and eighth graders, and we're going to specifically be looking at the overall average scores of their math and reading assessments. Those are the two major ones that they do, and they're also two categories that I think most people agree are pretty important. So here's what that looks like for all 50 states over all the years we looked at, and as you can see, it's pretty normally distributed. So far we're looking pretty good. Diving further into the data set, we had to pull financial data. We got that from the United States Census Bureau at census.gov. All that's public information. We looked at public and secondary education finance data for the years 2007, 2009, all the way to 2017, which are the years that these test scores were released. And at nces.ed.gov, you can see the same uh, test score average that I was just talking about. So let's start talking about our procedure. So we wanted to do a mix of supervised and unsupervised learning where we look at some relationships between this expenditure and performance, and we look at which of the financial features are most correlated or that the performance is most dependent on in that section. And then afterwards, we do a short section of unsupervised learning, and we do some clustering analysis with the Gaussian mixture model. We want to look at the correlation between the most dependent expenditure performances and that, and kind of compare between states, see what groupings we can find. And so here's kind of a chart of how we're going to do that. We're going to actually start before any of this with some Pearson correlation, just seeing how our individual features are correlated with, with our goal, as you can see back here, overall score average. And then we're going to move into multiple regression and a ridge regression. That's just a linear regression over multiple features, and then we're going to do it again, but we're going to do it with some suppression of high things. We're going to see if we have any overfitting problems. So moving on, then we're going to do the Gaussian mixture models, as I already mentioned. So areas of investment that we looked at, right? Before you do your supervised learning, you have to know what your X's are. And so our X's are all the different ways that these schools are spending money. So we have instructional spending, support system spending, those are pretty self-explanatory. Pure pupil of the same things, instructional support systems, the number of pupils. And then we have spending in other categories, like on instructional staff, paying the teachers, general admin, that's your county people. Every school has a central county that they have to pay people for, school admin, principals, vice principals, PP&E, that's fancy accounting for property, plant, and equipment. And what that it would be in the sense of a school is like the actual school buildings, you know, the desk, other just essential things for them to do their business. Transportation, most schools have a transportation system that we wanted to take into account. That's going to be buses, um, bus drivers, etc. Other, it's a category that the census had, and so how does that affecting that? We will know. Construction and instructional equipment. So that now that we have our X's, we can, like I said, do a quick Pearson correlation check on all of those. Uh, and this is just a quick correlation check between these factors and overall score average. And as you can see here, the highest correlation is per pupil instructional spending at a correlation of 0.38. And pretty interesting here, per pupil instructional and support systems are pretty high, as you can see, and most other things aren't really significant compared to that. You see instructional equipment is pretty significant here. So having looked into our Pearson correlation check, we can now move on to the next step in our process, kind of the meat of it, the supervised learning, right? And of the supervised learning, the biggest part that we did was our multiple linear regression. And this is actually really nice. You can see the performance details here. We've normalized all of the data so that instead of ranging in dollar values in hundreds of thousands and millions, we have them ranging from 0 to 1. And the other thing that we did before this regression is we just took a training test data split of 0.2. So we've reserved about 20% of our data in order to test at the end. And on that testing, we see that we're getting a mean absolute error of 0.0151 and a mean squared error of 0.0003 and a root mean squared error of 0.0176. So as you can see, the multiple linear regression is performing pretty well here. And we can go ahead and look at the results. And here we just have a graph of the coefficients from instructional spending to support system spending, etc. And you can see that the highest positive coefficient that we have is per pupil spending, followed by PP&E, and then our two most negative are instructional spending and per pupil support system spending. So what you can see here is that per pupil instructional spending is going to be one of the most important factors in influencing or positively influencing this overall average scores of a state. And that makes a lot of sense because it makes sense if you're spending money on each student to educate them, you're going to have a much higher average test score. And PP&E, once again, that's just the money spent and had in schools and other essential property and equipment type deals. So it makes sense for that to be important as well. And we've boxed up these important factors here. There we go. Yeah, so then the other type of supervised learning we did was ridge regression. And you can see here it says ridge regression shrinks the coefficients, reducing the model complexity and multi-collinearity, which allows us to cross-check influential factors with multiple regression. Basically, what this is saying is that in ridge regression, we're taking into account how large the coefficients are here, and we're not letting overfitting happening, right? And so we've got it on two different settings so that we aren't underfitting, and it says here, higher A value, more restrictions, lower A value, more generalization, right? So we can move on to the results of that. And you can see that the coefficients for per pupil instructional spending, instructional staff, PP&E, these things, which were high in the last one, become considerably less, however, still the most significant. And indices such as instructional spending per pupil support system spending and general admin are also considerably less. So in general, it's going to make your things less, but we see the same kind of trend in this as with our other multiple linear regression. And so we say we get similar results here with multiple linear regression performing slightly better. And next, as it says, looking forward, we're going to use a Gaussian mixture model regression in order to look for potential clusters and see what extra information we can glean about our data. And so here's the section of unsupervised learning. And here we have PP&E versus overall score average. And you can see that it kind of splits into three states over here. Each of these dots is a state. They're not labeled. And then the rest of them over here. I happen to know that these three states are in no particular order, like California, New York, and Texas. And they're very, you can see they have a lot more, right? And moving on over here, we have these kind of models over here. And once again, we have these over to the right. And this is a trend that we see on all of the things we looked at. And you can see PP&E and instructional spending. What we're looking at here is the most uh, way back here. These four factors that we found that were the most important. Those are the ones we wanted to look at more. And so we go to PP&E and we see this kind of island, and we go to instructional spending and we see some weird stuff going around over here, but also a similar island. And then here on per pupil instructional spending, this is where we see the biggest kind of separation from that trend. As you can see, there is a little bit of these outliers, but they're actually not the same three. And you can see that they're more in a linear line. So per pupil instructional spending seems to at least partially take out some of that big state versus small state split that we're seeing here. And finally, per pupil support system spending has a similar thing. So these two aspects kind of, and three over here as well, but these two aspects kind of taking away that split that we see in these two Gaussian mixture models. And that allows us to move on to our conclusion. So what have we learned? Well, from our supervised learning, we had some solid regression models where we saw a relationship between financial components and performance. And we looked at those features and we saw that some of them were a lot more important than others to a very significant degree. If you remember way back here, even in the Pearson, per pupil is a solid 10 times greater and 20 times greater than support and instructional spending. And that trend is followed over here where we see both of the per pupil instructional and support system spendings being very high in their correlation compared to the other things and further on in Ridge. And then later on seeing in the Gaussian mixture model that states with a high population and spending cluster, kind of they cluster together, right? And so what we can conclude from this beyond the previous conclusion, which is these important things that people should be looking at when they invest, we can see that there is no one size fits all model. And in fact, probably an interesting follow-up would be a farther state-specific analysis where we kind of take out the size of the state effect and look at that. I hope you've enjoyed uh, this presentation on uh, financial data investment in American public school systems versus uh, the performance. And I hope you've learned something about maybe how you might want to look at spending in your local school areas or just about machine learning in general. That concludes our presentation, and thank you for listening. Goodbye.